Assalamualaikum warahmatullahi wabarakatuh. So this is chapter 5 part 1. So for part 1 we will cover on the basically chapter 5 is on the process control and instrumentation. So for part 1 we will cover on the product quality and quantity, control systems, which is manual and automatic controls. Okay, so basically only two subchapter we will cover inside this part 1. Okay, so the learning outcome for this chapter 5 is students should be able to understand the product quality, product quantity for different type of chemical industry. Next, students should be able to distinguish the application of manual and also automatic control. Next, students should be able to recognize the control and instrumentation symbols. And lastly, students should be able to understand the type of control system. So I will explain in detail one by one learning outcome in the next slide. Okay, so first thing first, which is subchapter 5.1, we will cover on the product quality and quantity. So for the introductions, when we dealing with the chemical productions, the choice of the quality and also quantity for the chemical production are based on many factors. So we can see that the chemical production is based on the quantity and also quality. So basically, like we all know that in the chemical production we have a batch process, continuous process. So basically, for normally the company or the industry will use the batch process when they want to highlight, they want to focus on the quality of the product. Meanwhile, if the company or industry using the continuous process, mainly they want to target to focus on the quantity of the product. So basically for the continuous, they will run in a mass production. Okay, so now I will move on the type of the chemicals. Okay, we have one type of the chemicals that been produced inside the industry is specialty chemicals. So basically this specialty chemicals is a very unique chemical. It's a mixture of different chemical substances that designed and produced in order to be applied to a specific application. That means only specific product or specific application will use these specialty chemicals. So the formulation and also properties of specialty chemical is very unique because it cannot interchange two different specialty produced by two different suppliers. So that means each supplier will produce their own specialty chemical. So it's hard to see the specialty chemical with the same properties and formulation for a few suppliers. So this specialty chemical normally is produced in a small scale. So this specialty chemical also is produced based on the demand of consumer. So this specialty chemical is depend on the consumer, and it can be produced seasonal. That means maybe at the end of the year, the consumer need to use this special chemical, then the producer will produce depend on the demand of the supplier. Okay, the other information on the specialty chemical, the cost is quite the cost for the R&D is quite expensive, and but this specialty chemical have potential to deliver better and can gain stable profit, because due to the high price of this specialty chemical, so this specialty chemical can ensure the stable profit. Okay, the example of specialty chemical is drugs that produced from the pharmaceutical industry, special grade of fertilizer, seed for agriculture purpose. Okay, so now we move to the fine chemical. So like specialty chemical is a unique chemical that have unique properties, but for the fine chemical, the chemicals is complex, single, pure chemical substance. It produced in limited quantities. Same goes to specialty chemical. So normally this fine chemical is produced by the multi-purpose plant by multi-step batch chemical or biotechnology process. Normally this fine chemical is produced around less than 1,000 tons per year, and the price is very expensive. So this fine chemicals is applied as a starting material for specialty chemicals. So basically it's been used inside the pharmaceutical and also agrochemicals. Okay, next we have a commodity chemical and also known as a bulk chemicals. So these bulk chemicals normally are made on very large scale, so to satisfy the global market. The example for this bulk chemical is the basic raw material for oil and gas product. So the product contain almost identical chemical structure and purity, hence it can be easily to interchange lah. So the example is like hydrocarbon lah. We have methane, propane, ethane. So this type of chemicals can be produced in a bulk chemicals. They also have slightly identical chemical structure. So for the bulk chemical, normally we use the continuous plant, and the cost for this bulk chemical relatively low. So the other example of bulk chemical is ammonia, ethylene oxide, the one that we produce in a large number. Okay, finish with the product quality that consists of type of chemicals and also type of process. So now we move on the manual and automatic control. So basically the key characteristic of control is used to interfere, influence or to modify the process. So basically the control system is a device. So this device is used to manage or command or direct or regulate the behavior of other system or other devices inside a whole system. So we have two types of control system, which is manual control system and also automatic control system. Okay, for the manual control systems, all the controlling variable like manipulated variable, control variable, disturbance variable have to be calculated manually by the operator. For example, like the operator must manually go into the equipment and it need to calculate the variables such as manipulated variable and also control variable. So based on the calculation, and then they need to key in inside the control systems. So that control system will react, depends on the input from the operator. So this operator must be trained and experienced operator. Okay, for the automatic control systems, normally is the application of control theory for regulation of process without direct human intervention. That means it's fully automatic, fully computerized for the automatic control system. So basically, the automatic control system, the operator need to define only the set point. So operator need to define the set point. For example, like they need in the reactor, they need the temperature inside the reactor is around 100 degrees Celsius to achieve the reactor requirement. So the operator need to define the set point first, and then the system will program the sensor, then it will try to reach the desired output automatically. So for this automatic control system, they do not need to do the manual calculations, because everything is programmed inside the control system. The example of the automatic control system that we commonly use inside the industry is SCADA and also DCS. So SCADA is supervisory control and data acquisition, and DCS is distributed control system. So this one you already learned inside your process control subject before. So I guess you can understand, you can get the idea of these two types of automatic control system. So for the automatic control system, for the control system, we have a few hardware part that been used. For example, like sensor, controller, and also control element. So basically, sensor is used to measure the system variable. Commonly is control variable. Okay, it serves as the signal source in automatic control. So controller is a piece of equipment to perform the function of comparison and computational. So comparison mean here, when we input the set point to the controller, and at first we will input the set point to the controller, and the sensor will measure the control variable. So from the measurement from the sensor, the sensor will transmit the signal to the controller. That signal, it will compare with the set point, and from the comparison, it will the controller will make a decisions and send the information to the control element, which is like actuator or valve. So this valve will take an action whether to open or close the valve, depend on the controller decisions. Okay, so software of a control system. So this software of control system associated with a control system. So this software control system is associated with a different type of variables. For example, like control variable. So control variable is the variable that been measured. Normally this control variable is the output from the process. It can also be the input. It's depend on us whether we want to control the variable at the input or output or inside the system. So the other different type of variables that been used inside the control system is set point. So set point is the objective of the control system. So if we decided if the set point is, if for example like in the reactor, the temperature is 100 degrees Celsius. Okay, we want to achieve this temperature. So this is the objective of the control system. So the system need to be controlled up to this set point. So we have the other type of variable, which is manipulated variable. So in order to achieve the control objective, which is temperature around 100 temperature equal to 100 degrees Celsius, we need to adjust or alter maybe one or more variables. So the one that been altered and also adjust, that one is called as a manipulated variable. So in conclusion, the control system Portman adjusts the manipulated variable to maintain the control variable at its set point. So why we doing like this? Because we want to meet the requirement of keeping the stability of the process and also suppressing the influence of disturbance. Okay, so what is disturbance actually? Disturbance are load variables. It represents input variable that can cause the control variable to deviate from their set point. Okay, for example, like temperature just now in the reactor, the temperature need to maintain 200 degrees Celsius. Okay, we have a heater here. So suddenly the steam flow inside here, the flow of the steam is high. So when the flow of the steam is high, maybe the temperature inside here will increase beyond 100 degrees Celsius, like 100 degree 105 degrees Celsius or 110. So this steam flow rate would be the disturbance, the load variable for the system. So this is the figure of Portman inside the control room. So we can see here all the equipment, in this panel shows the each equipment inside the chemical plant. So you can click on the equipment to see the condition of the equipment. So for example, you want to know about the reactor, and then you click reactor, you can see the temperature, the pressure, the flow in, the process taking place inside the reactor. So basically inside this panel we have many information on the equipment. Okay, moving on to the SCADA. So SCADA, like what we learn inside the process control subject, is one of the automation control system. So the SCADA system deploy multiple software and hardware element. It be used to monitor, gather and process data, interact with and control machines and devices such as valve, pump, motor and more. And this SCADA is connected to HMI software, and it also been used to record event into a log file. Okay, so for the SCADA, basically the information from sensor or manual input are sent to the PLC. So PLCs is a programmable logic controllers, and from the PLC it will send the information to the computer with the SCADA software. So this is the figure of the SCADA. So we have information from sensor or manual input, and will be sent to the PLC or RTU. So from the PLC or RTU here, the information is transferred to the SCADA computer that consists of a SCADA software. Okay, so basically this is the example of the tank. Okay, so this is the low level pressure and also high level pressure. So when the system achieve the low level pressure, this valve will start to open. when it reach at the top of the level pressure, at the top of high pressure, so this valve will start to open. Okay, moving on to the subsystem in SCADA. So we have RTU, which is remote terminal units. This RTU is used to connect to sensor in the process, and it's used to convert the sensor signal to digital data. Okay, we also have a programmable logic controller, which is PLC. This PLC is connected to sensor in the process, and the function is to convert the sensor signal to digital data. So basically, RTU and PLC it's have a same function, but different type of hardware. For example, like you have CPU brand HP and CPU brand LG. So basically two same thing but different brand. So okay, we also have a telemetry system. It's used to connect PLCs and RTU with control centers and data warehouse. And lastly, we also have HMI inside the SCADA. So this HMI is the apparatus or devices which process data to a human operator. So through this, the human operator monitors and interact with the process. So this is the example of the SCADA system inside the control room. So SCADA and DCS basically it shows the same thing. It's not really the same thing lah. The purpose is the same, which is they want to show the chemical plants inside the computer, to simulate the chemical plant inside the computer. DCS also the same, but the system is different. So basically DCS is a distributed system. So it's referred to a control system in which the controller element are not central in location. So this DCS is distributed throughout the system, with each component subsystem controlled by one or more controller. Okay, later on I will show the figure. So the entire system of controller is connected by network, and also is connected by network for communication and monitoring. So basically the difference between SCADA and DCS, SCADA is used for data gathering, DCS is used for control process oriented. So SCADA generally support storing of database, whereas DCS does not support. So DCS is a process control system that uses a network to interconnect sensor, controller, operator terminal and actuator, whereas SCADA may be called HMI, human machine interface. This HMI, we also can call SCADA as HMI. So it's used to monitor or to control chemical, physical or transport processes. So for DCS, it consists of one or more controller to implement advanced process control technique. Meanwhile, SCADA cannot carry out advanced process control technique. So this is the real figure of what is SCADA, what is DCS. So basically DCS, from one sources, one system, it will be connected to each of the controller units. For example, like here we have pump, we have motor. But for SCADA, the system is one SCADA is for one single unit. Okay, so this is the end of my lecture for chapter 5 part 1. Okay, you may need to see the other video for chapter 5 part 2. Thank you.